the flexible walls. I'll come to this a little bit later, and also to assist in the harvesting process. And when we follow our kind of design criteria, but also I think general ones for us, of course, closed water cycles, I mentioned that already. Safe on water, make it location independent. You can have also much better control about the waste streams. So we are actually at 0.5% of the system volume, water renewal rate per day, so pretty close already. Systems head loss, I think it's a really important cost driver in terms of energy requirements. In a raceway system, you have almost no head loss in the raceway itself, but of course we use drum filtration, protein skimming, we have trickling, degassing devices. So summing all head loss up, we come to 2 meters, but this is much less. You have a conventional design for round tanks. Laminar flow in a raceway. I showed this video of the Gilbert sea green. It's, in our opinion, better than round tank designs because you have everywhere the same velocity. The fish can be adapted to that. We have a more spontaneous behavior, like we have seen also in the video, and also the removal of solids is working pretty fine in these kind of systems. High circulation rates, I think I explained this pretty well, and then multi-batch stocking. It's really an important thing, and this you can achieve in this kind of raceway. So when you have a round tank design, you have to split the fish. In the beginning, the round tank is too big, and at the end it's too small. Then you have to split the cohorts, so the tanks, they can't grow with the size of the biomass. So in our system, it's totally different, and I tried a little bit to animate that. So you see now the white batch for the shrimp, and it's coming from the nursery into the grower basin. And when the batch is growing, we can extend the size of the compartment, and we have a stocking interval every 4 weeks. So every 4 weeks, the shrimp is transferred to the next basin. So we have 3 different basins, 3 different size groups, age groups, and then we have 4 weeks time to harvest the last batch. And what you see, and this is really interesting in shrimp, you have harvesting in the batch the same amount of shrimp like the standing stock in the grower facility of 3 different size batches. Why is that? Like the standing stock can be 5 tons. Here in this example of a 1,000 cubic meter tank, we can produce annually up to 65 tons with that. So it's 13 times the standing stock. In fish, where you have production cycles typically of 1 year, it's 3 to 4 times. So, but much more than all in, all out. And this is a huge advantage. It's like a conveyor belt. And this is increasing the productivity. It means that we have a standing stock, which is quite close to the carrying capacity, and all day in a year at the same level, the same feed load every day. It makes operation much easier, and also for off-flavour control, it's really important. This I just want to name it here, our water quality recommendations. I know there's a lot of discussion about that. What you have to consider here is also that you can have, you can make a scientific research, and you can analyze what is the ammonia level you should have for your species. But very often what is not addressed, that you have a mix of a lot of different parameters. And it's the freedom to operate, in our opinion, driving us to have the best water possible and not to be, let's say, 10% below the acceptable limit for certain values. This is something you have a little bit to consider. And when I want a little bit to address our kind of design recommendations, so we would address a high water circulation rate, low head systems following the raceway philosophy. Minimizing piping, so I think there's no real need for that. I mean, especially in the primary water circulation. So there are really intelligent raceway designs which avoid that. An increase in basin volume area rate. This is also quite important. So every area there's a biofilm on it, and the control of this biofilm, it's not always easy to do. So when you have the high velocity, no problem. If you have the activity of the animals, no problem. Especially, for instance, gravity-driven pipes with low velocities, they have a certain biofilm formation, and this is doing a lot of problems to the system in terms of H2S, off-flavour, reducing also head loss, increasing head loss. and also like the trickling tower, for instance. The trickling tower is pretty much the same. You know, you have a lot of biofilm formation on that. I've seen many farms in the past. Yeah, they have trickling towers which are not accessible. So if they are not accessible, they can't be cleaned. If you can't clean it, then you have massive problems of off-flavor. That's for sure. You know, so that's something you have to recommend. Minimize uncontrolled biological areas like hollow areas, for instance, pipes, fixed bed filtration. Of course, it's quite cheap, but it's not really functional. Flexible raceway design, as I mentioned, use of automatization, robot technology. Of course, this is something what fits in just at a certain scale. I'm aware of that, but I think this has to be the future to increase the profitability of the business. And at the end, clear water. Yeah, we do clear water shrimp farming. Everybody says there's no need for clear water and shrimp. I totally disagree on that. It's a need. And I give you one example, and tomorrow I will talk more about that. This is an image of our urban mangroves in our farm for shrimp. And you see a crystal clear water. And what we do with that is we use computer vision. So biomass control in shrimp farming is one of the biggest challenges. And you see we have just cameras above the water. And we do every minute we do an image and analyze that image. So we count the shrimp, we do the length detection. We even did a proof of concept on stress detection in the shrimp. So this is for us the next step. So we can gain much more control about operations. So you know that when you don't know your lightness, how you can do a good feed management. Yeah? So that's the problem. And with this example, I would like to end my talk. And thanks for your attention.
Thank you so much. We have time for at least one question. So, any questions for Bert? We'll also be presenting tomorrow on more details, but no questions? Okay.
What were some of the markets for the waste that you mentioned, the concentrated waste that you're doing, that you result of?
Yeah, that's a good question. In the very beginning, we had a lot of projects because this is not so easy to find the right, to address the right markets for that. So we had a project where we were working with seaweed, microalgae, halophytes. Halophytes we see quite the most feasible addressable market for us because our products in shrimp and fish are going to food service, for instance, and they are looking always for new inventions. And especially halophytes, it's kind of a new product to food service and restaurants. You know, that's quite interesting. And another waste stream we did some trials where we did a carbonization of the sludge to make a biocoal from that. And the biocoal has a porous structure. In the porous structure, we load with nutrients also from the farming process. So this is kind of the development of an organic fertilizer. You know, this we have under development. It's shortly before we enter with that product into the market. As we have not the big scales, you know, we are addressing more products to sell that story also to the final consumers. You know, so that means okay, we address issues of sustainability, of freshness, local farming. And then we can make the story like round to have a circular economy. You know, we have a nose-to-tail marketing. So we make from the shrimp, we have a processing, we have the tails, we do soups on the heads. We make product out of everything, even the grouper. We have nose to tail. Right? We sell everything, and then you can say, okay, and now the next step, we even sell half the weight because we create new product out of it. You know? So that's the philosophy we follow.
Thanks again, Bert.
Yeah.